This is question 3 from the GATE 2017 session 1 EC paper. This question has to do with the linear dependence of real valued functions y1, y2 and y3 as follows. We have been given 4 statements about the linear independence or dependence of these functions over some intervals on x, and we are asked to find out which of the following combinations of these statements are true. Underneath the question, you will find the title of the NPTEL course or video relevant to this topic. So first we'll move on to a little bit of background. Functions f1 to fn are linearly independent. These are functions of single variable, so they are linearly independent on a set S if you form a weighted summation of these functions, let's say you get this function f, then if that function is 0 on the set S, that is for all x on S, f of x, for all x in S, f of x is equal to 0. If this is true, then it must imply that all the constants are equal to 0 in the weighted summation. So that's the definition. Let's move on to the solution of this problem. I will set up my 3 functions y1, y2 and y3 and my set S as so. Why have I chosen this as a set S? I'm going to prove that all 3 of them are linearly independent in this set. And so the set -1, 0 and the set 0, 1, which are subsets of this set, it will be linearly independent on them too. And why am I interested in that? Because they are the 2 options, which is option 1, right, the set of -1, 0 and the interval 0, 1. Basically the idea is that 1 and 3 are true, and I'm going to prove it in a single shot by taking S as -1, 1. So f is the weighted combination of the 3 functions. So you get c1 plus c2x plus c3x squared. Now the idea is that for all x, f of x is equal to 0 for all x belonging to S, right? So what about f of 0? F of 0 is just going to be c1, right? This is now 0 because, well, 0 belongs to S, and so f of 0 is 0. Next, what is f dash of x? Well, it is c2 plus 2c3x. And we know that f of x is a constant function, right? F of x is a constant function, and so its derivative is 0, which means f dash of 0 is equal to 0, which implies c2 is equal to 0. And similarly, f double dash of x is just going to be 2c3, and the double derivative is, again, this is also a constant function, so its derivative is constant, right? Which means we now have f double dash of 0 is equal to 0, and so we get that 2c3 is equal to 0, which implies c3 is equal to 0, right? So we started with this assumption and we've gotten c1 equal to 0, c2 equal to 0 and c3 equal to 0. And so we've proven that the 3 functions y1, y2 and y3 are linearly independent on this set S. And so therefore options 1 and 3 are true, which is option B of this question.